With this lesson, we're going to be working on ratios and rates. And basically we have, three objectives that we want to accomplish. Express and simplify a ratio or rate. We want to be able to calculate and interpret unit rates, use them to answer some questions. And we'll also use rates to solve some word problems. So getting right into it. A ratio is nothing more than a comparison of two numbers. Man, this is just glitching out on me pretty hard right now. So for instance, if you want to compare two numbers, we can say 3 to 2. That's a ratio. That's a ratio. And there are three different ways of expressing that. We could use the word just 3 to 2. You also use a colon for 3 to 2. And the most common one that gets used is a fraction, 3 to 2. All of them are read the same way, 3 to 2, 3 to 2, 3 to 2, whether you use words or the colon or a fraction, they're all read the same. And some of these are pieces that, frankly, you've worked with a ton, especially with rates, because a rate is a ratio. So we are going to compare numbers. We will have two numbers, but the important characteristic, they have labels. And so the easiest one that we can create right now, let's just say, let's look up at the ceiling and count. How many lights are turned on versus how many lights are turned off. And so we'll simply create a comparison of the number turned on, the number turned off. So count them. How many lights are turned on? Okay. Looking up, how many are turned off? There's our rate. It's a ratio because we're comparing numbers 6 to 3. And it's a rate because we're comparing numbers 6 lights on to 3 lights off. Just like you could simplify fractions, you can simplify ratios and rates as well. What number is going to divide into both of these? Well, of course, we could divide by 3, which would give us 2 of them on compared to 1 of them off. There's a simplified rate. And of course, we can write this with its 2 other formats as well. We could say 2 of them on to 1 of them off. Or we could use just words, 2 lights on to 1 light off. None. This is one of our objectives, being able to just simply count something and express it as a rate. Being able to simplify it, same way that you simplify fractions. That's one of them. Here's a piece that I think is kind of pretty interesting. Here are the wing lengths measured in centimeters for 3 different kinds of birds. We have an eagle that has the length of its wing is 209 centimeters. Its width is 30 centimeters. A jay is 47 long, 12 wide. A gull is 83 long, 8 wide. And what I'd like to do is to create a ratio for each of these, length to width. How would we do it? Just create a fraction. 209, 30. There's our ratio. And we've got 47, 12, 83 to 8. Creating ratios is no more difficult than writing down a fraction, just comparing the numbers. Interpreting it is a little bit different. Which one of these birds has the largest ratio for length to width? Well, of course, it's obvious to look at it and say the biggest wing belongs to the eagle. It's the longest, it's the widest. Obviously, the eagle is the biggest bird, but that doesn't mean that it has the largest ratio. In order to compare the ratios, we could, well, it'd be pretty simple. We could just take this stuff and put it directly into a calculator. 209 divided by 30 and simplify it out. So 6.96, we'd round that and say 7.0. And you should pause the video, grab a calculator, crunch the video, crunch the numbers. What ratios do you get? Right? 47 to 12 simplifies 3.9, and 83 to 8, there's 10.4. So, which bird has the largest ratio? Obviously, since 10 is the biggest number, we'd be able to look at it and say the gull has the largest ratio. I'd like to throw a little bit of a biology fact in here that you may not be aware of. It's a well-known piece, and the piece I'm going to put down right now, you're not expected to know, of course. It's just an instance. This ratio of how long to how wide is called an aspect ratio. And you're probably familiar with the idea of an aspect ratio because of TVs. In particular, you ever been looking through the settings on your TV and saw 4:3? Or looking through and saw 16:9? Those are your aspect ratios. A 4:3 aspect ratio, so like 4 feet wide, 3 feet tall, 4 inches wide, 3 inches tall. If you maintain that ratio, that's full screen. And 16:9, that's widescreen. That's why your TV has different settings, so that you can change it to match the programming, something in full screen or widescreen. Well, the aspect ratio for these birds, there's a well-known biological fact about it. In particular, birds that have a really small ratio tend to be rather quick, agile. That is, they can change direction very quickly. But if you have a really big ratio, the larger the ratio is, the less agile. They can't really change direction super fast. But those are birds that are really awesome at gliding. And so if you understood this fact, you can go back to the top and say, which one of these birds is going to be the most agile in flight? Well, it's the same thing as saying which one has the smallest ratio. Because the J has the smallest ratio, it's going to be the most agile. That is, something like a blue jay would be able to change directions while flying quicker than an eagle, quicker than a gull. And if you've ever watched seagulls fly, you ever see watch a seagull quickly change direction? Of course not. What do they spend all day doing? They just sit up at the top and they circle and they circle and they circle, and then eventually they're like, hey, fish, and then they dive bomb. Some of them doing it. Not all gulls act the same way, but when you watch gulls, because they need to be able to spend a huge amount of time in the air circling, because they need to glide for such a long period, their wings tend to be really, really long, but not very wide. And if you ever got into hang gliding, they have different style hang gliders that play around with this. If you have a hang glider with a really small aspect ratio, that's a piece that you could use to change direction very rapidly. You'd be able to dive bomb. You'd be able to do all kinds of pieces, increase your G-force. But if you had a large aspect ratio, that's a hang glider that you'd be able to spend, like 30 minutes. You could spend 30 minutes just gliding through the air because the wing is designed to be able to do that. Okay, changing the road directions, or changing paths a little bit, getting away from the aspect ratio. There is one really common way that people use rates all the time that nobody ever stops and thinks about. Miles per hour is the rate. In particular, when you're talking about driving, you ever see somebody say, oh yeah, I drove 255 miles in 3 hours. Hey, David, you're driving up to my house. How fast are you driving? Oh, don't worry, Mr. Fry. I'm driving at a speed of 255 miles for 3 hours. Yeah, nobody ever talks that way. Whenever you're talking about speed, it's pretty weird to use something like a 3 here. You could, but it's weird. Whenever you're talking about speed, you don't say 255 miles in 3 hours. Instead, you look at it and say, I want to know what's my speed per 1 hour. And this is what a unit rate is. Whenever you're working with a unit rate, those are ones that have a denominator of 1. And so all we're looking at is something like this, 255 miles in 3 hours. We want to be able to get a unit rate with 1 hour. Well, how do you change something from 3 hours to 1 hour? Just divide by 3. That's all unit rates are. You're just dividing it out. 255 divided by 3. Numerator divided by denominator. And 255 divided by 3. That gives us 85. So there you go. You're driving at a speed of 85 miles per hour until the cop catches you. In which case you wind up going 0 miles per hour for a little bit. Calculating a unit rate is rather helpful because you can use it to start making comparisons. Perfect example, this last weekend I went out shopping at Walmart with my wife, and we needed to go buy some laundry detergent. And my wife really likes those Tide laundry detergent pods. Alright, and what we wound up doing is we got there and we were looking at the different ones, and of course they've got the big size, you got the small size, and what wound up happening is 2 different things we're looking at. There was a big one that was 1997, and that one had 81 pods in it. And I was looking at it and saying, this is the one that we should buy. But my wife looked at it and said, no, because they've got the smaller one that's on sale. And the smaller one was on sale for like $2 off, but that one, if I remember correctly, was $9.97 and it had 38 pods in it. And so we were simply looking at it and saying, which one's going to be the better deal? Which one should we go buy? And of course, being a math teacher, I thought about, hey, this is unit rate. We can actually compare these things. And being a person who is incredibly cheap, I want to save a little bit of money. I'm really super cheap. So yes, we actually stood there in Walmart. I pulled out my phone. I grabbed the calculator because I wanted to be able to prove, like, this is the one that we should buy. Well, what do you think? Which one do you buy? The big one at regular price or the small one for sale price? Well, if we're going to compare them, the main thing that we want to be able to say is how much money are we spending per pod? I want to know how much it's costing us to get 1 pod because they're the same thing, just bigger, smaller container. And so all we wind up doing is taking and dividing out by this 81, essentially just simplifying the fraction, dividing out by that denominator because that's what gives us the unit rate. And 1997 divided by 81 pods. Again, we can grab our calculator quick and say $19.97 split up 81 of them. Gives us 0.2465. And to simplify that, make it a little bit easier, that's saying 24.65 cents per pod. That's what it would cost us the big one. To get 1 pod, it's basically a quarter per pod. Well, do the same thing. Pause the video, crunch the numbers. What do you wind up getting? So Riley gave us 0.2623, which is telling us then that that's 26.23 cents per pod. Based on that, which one did we buy? Of course, I'm cheap. We bought this one. This whole piece, 24.65 cents versus 26.23 cents. That means we are saving 1.5 cents per pod. And at 1.5 cents per pod, well, from 81 pods, I'm sitting there at Walmart saying, hey, that's going to save us about $1.25. That's a box of Little Debbie's. And I like my Little Debbie's, so we're going to buy the big one so that way I can have my box of Little Debbie's. And it matters to me because, you know, again, I'm cheap. Saving that dollar actually meant something to me. All right, ratios. I mentioned before that when you're working with ratios, the labels are of course important. Anytime you're working with rates, you want to write down the labels. And labels need to match whenever you're going to talk about things being equal. In this instance, we've got a jet. Actual speed for a jet, 540 miles per hour. How fast is that in miles per minute? Well, of course, if we're going to do a conversion, the labels have to match. So the very first thing we're looking at is making labels match. How about hours and minutes? Let's get rid of the label of hours. How many minutes are in an hour? Okay, so 1 hour we could rewrite as 60 minutes. And then to change it from 60 minutes to 1 minute, we'll divide by 60. So same thing in the numerator, divide by 60. 540 divided by 60. That's 9.
Oh, it's 9.
Kind of crazy to think, isn't it? The jet flies 540 miles per hour is actually flying 9 miles per minute. It just seems crazy. 9 miles per minute. And that's not even going to break the sound barrier. If you're talking like a military F-15 jet, they're even faster than that. Last problem for the day. When you've got guys who work with duct work, have you guys seen the movie Die Hard? He has a crap load of time where he's like crawling through the duct work in there. They like to put it in movies like duct work is so big that people can crawl through it. But for the vast majority of buildings, the air ducts are not big enough for most buildings. In most buildings, people can't crawl through the air ducts. Certainly not the ones in your house. But let's say you're sitting there at home and you're like, dear God, what is that stench? Something smells terrible and it's coming out of my air conditioning system and it's just something reeks. Like something must have died in there. What are you going to do? Start tearing apart all your ductwork, trying to figure out what's wrong? And it's not like you can sit there and say, oh, well, here it is. I know exactly where it's coming from. What HVAC guys can do sometimes, a lot of them will have cameras that they can put down, and some of them just feed a camera through the system. But I've also seen ones where they create like a little mini robot that they actually drive through. They can drive through your duct system using these little robots. Now, of course, you don't want them to go too fast either. This one can drive 1 inch in 3 seconds, which doesn't seem like it's very fast. But again, you don't want to. It's not like you want to have a remote control car cruising through your ductwork. You know, it's going to go slow so you can get a good camera image. How far could that thing drive in 1 minute? Well, we'd be able to set this up pretty easily. 1 inch in 3 seconds. We want to know how far it's going to drive in 1 minute. Well, this is one that, if we're going to answer this, I want to know not how many inches it's going to be, how many feet is it going to go in a minute? Well, once again, the labels don't match, so we have to start working with the labels. In particular, we'll say 1 minute is 60 seconds. And to change 3 seconds into 60 seconds, of course, we got to multiply by 20. So carrying that through with equivalent fractions, 1 inch times 20 tells you this little robot can go 20 inches in a minute. Not very fast.
So that's 1 foot.
So how far is that then? In feet. Well, of course, we've got to set up and do another conversion. How do you convert inches to feet? That's where we divide by 12. 20 inches divided by 12 will give you feet, so grabbing our calculators, 20 divided by 12 gives us 1.666666666. So if we're going to use a repeating decimal, that's 1.6 repeating feet. Or we could say 1 2/3 of a foot. And of course, if we were to take 20 divided by 12, it gives you 1 remainder 8. So that would be 1 foot with a remainder of 8 inches. All three of those are correct answers. They're just correct answers in different formats. And you'll notice each of these examples that we looked over give us exactly what we needed. We were able to solve some fairly complex word problems using a ratio, using a rate. We were able to interpret doing some simpler conversions. We were able to determine, like, what should I buy, how fast am I driving, using unit rates, and of course, if you can combine it with some of your other classes, like biology, physics, like a lot of classes, you'll wind up using these ratios to make decisions. And ultimately, they all address our three objectives. You could use fractions to write up a ratio or rate, same way that you would simplify them. We could take unit rates, just divide out the denominator and interpret them. And by paying attention to conversions and the labels, we can actually solve word problems too.